Okay, this is a problem number 1 on section 3, chapter 7. For this problem, we need to construct a confidence interval estimate of the population standard deviation. This is the formula we're using for this problem. Okay, and this formula we use it for 7.1, this for 7.2, and this one for 7.3. Okay, for this formula we need the sample size, which is given here. We need the sample standard deviation, which is here, and we need the confidence level to get those critical values. Let me show you how to get those critical values from the table, the chi-square table. You need to click here on this icon, and when you click there, you will get this table right here. The confidence level is 95%. Okay, that means we have a 2%, 2.5% on the left and 2.5% on the right. The sample size is 25 and degrees of freedom is 25 minus 1. We have to look under the 0.025, that's the area on this tail, and on the number 24 we cross this row with this column, and this is our right critical value, 39.364. And in a similar way, we need to get the complement of this number. The complement of this number is 1 minus 0.025, which is 0.975, which is the area on the left side of this critical value. Okay, notice that 95 plus 2.5 is 97.5. okay, which is this number right here. Okay, that is using this row, this column and this row, the one of the 24, 4 degrees of freedom, we obtain that my left critical value is 12.401. So this is my right critical value, and this is my left critical value. The chi-square distribution is a distribution that starts on 0, is skewed to the right distribution. It's not symmetrical like the normal distribution, and you will always have positive values to different positive critical values, the one on the right and the one on the left. So let's go back to the problem here. So that's how you get these two numbers right here. Let's follow that formula. It says n minus 1. Well, n is 25, minus 1 is 24, times the sample standard deviation, which is 0.21, to the second power, all these divided by that critical value on the right, which is this one right here, 39.364. Careful, don't raise the denominator to the second power. That is my lower bound for this confidence interval, and my upper limit will be 24. Again, it says n minus 1 times the sample standard deviation to the second power, all this divided by the critical value on the left. So that is 12.41. Okay. Remember, we want the confidence interval for the standard deviation. This gives the confidence interval for the variance. So to get a sigma by itself, all we gotta do here is take the square root of this side and take the square root of that side, and that's how you get sigma by itself. Okay. Let me type that on the calculator. 24 times 21 to the, I'm sorry, 0.21 to the second power divided by 39.364, and we need to take the square root of this value. So per second, x squared, and let me press second answer. So that will take the square root of this value, and that will be 0.16. We round to 2 decimal places, so that is 0.16. That's my lower bound. Let's see my upper bound here. It will be 24 times 0.21 to the second power divided by 12.401. I press enter, and don't forget taking the square root of that. So I press second x squared and second negative to get the square root of this answer. Hit enter, and that's how you get the upper bound here, 0.29, if you round it off to 2 decimal places. And that's how you do this problem.